Okay, so let's take a look. It says guidelines for solving related rate problems. Identify all given quantities and quantities to be determined. If possible, make a sketch and label the quantities. Step 2 says write an equation that relates all the variables whose rates of change are either given or to be determined. So this is come up with your equation. Step 3 says use the chain rule to implicitly differentiate both sides. So find the equation, find the derivative of both sides. And then step 4 says after completing step 3, substitute in the resulting equations all known values for the variables and their rates of change, then solve for the required rate of change. In other words, so you found the derivative of both sides, plug in what you know, and solve for what you want. Might be easy, might take a couple extra steps that you actually have to think about. It says this table list gives an example of mathematical models from some common rates of change that can be used in the first step of the solution of a related rate problem. In other words, you're going to be reading word problems. How do you come up with the equation and how do you read what is given? So the first sentence says the velocity of a car is traveling for 1 hour is 50 miles per hour. So if they say let x equal the distance traveling, then you know velocity is the rate of change. So that would be dx dt. Well, they told you it's traveling at 50 miles per hour. So you know dx dt is 50 miles per hour. And it told you when that happens. It says you've been traveling for 1 hour, so that gives you t equals 1. So just in that one bit of information, they give you two really important pieces of information, x prime and t. Look at the next one. It says water is being pumped into a swimming pool at a rate of 10 cubic feet per minute. Because it's cubic feet, cubic, I know it has to be volume. Remember, area is squared, volume is cubed, so it's cubic feet, so I know I'm talking about volume. So they're talking about volume in a pool, they call it V, and we know that it's changing at 10 cubic feet per minute, so they're giving us V prime is 10 cubic feet per minute. A population of bacteria is increasing at a rate of 2,000 per hour. So they say let x be the number in the population, or essentially the population. We know that it's changing at a rate of 2,000 per hour, so we know x prime is 2,000. Revenue is increasing at a rate of $4,000 per month. So the rate at which revenue is increasing would be r prime, or dr dt, and that would be 4,000. Profit is decreasing at a rate of $2,500 per day. So that would be dp dt, or the p prime, right, the marginal profit. And notice here, I want you to see that it's negative 2,500. How did you know that it was negative 2,500? Well, you knew it was negative 2,500 because it says decreasing. So remember, anytime it's increasing, it's positive. Anytime it's decreasing, it's negative. So what are the formulas that I expect you to know for these problems? These are ones that I expect you to have memorized. Hopefully you do already. You should know that an area of a circle is A equals pi r squared. The perimeter of a circle, it says A equals, that should say P equals, right? The perimeter of a circle is 2 pi r, or you could say pi times the diameter. The volume of a sphere is 4/3 pi r cubed. The volume of a cube is length times width times height, but remember, if it truly is a cube, length and width and height are the exact same thing, so the volume would be s cubed. You should know the Pythagorean Theorem, which works for right triangles. That's the a squared plus b squared equals c squared. Again, that only works for right triangles. You should remember that revenue is cost times the price times the quantity, or x times p. And then to find the profit function, you always do revenue minus cost. So why do we care about this? Well, imagine if we looked at a equals pi r squared. Remember, we have to assume that area is a function of time and the radius is also a function of the time. So what would happen if I took the derivative with respect to t of both sides of this equation? Well, what's the derivative of the area? Well, you would say it's a prime. What's the derivative of pi r squared? Well, remember, pi is just a number. So this would be 2 pi times r to the first power, but then you would need to multiply it times r prime. So the idea is they might give you at what rate the area is changing, and they might give you a length for the radius, and then they would ask you for what rate is the radius changing, or r prime. But there's three variables there, a prime, r, and r prime. They have to give you two of those three variables so you can find the missing third one. And you could do this with any of these different functions. For instance, consider that Pythagorean theorem, a squared plus b squared equals c squared, right? Imagine taking the derivative with respect to t of both sides of this equation. If we did that, what's the derivative of a squared? Well, remember, the variables don't match. A is a function of t, so that'd be 2a prime. The derivative of b would be 2b, but then you need the b prime. And then on the right, the derivative of c squared would be 2c prime. So there's a bunch of information there that has to be given, but you would plug in the given information, and then you would solve for what's remaining. So I hope that gives you an idea of what you're going to be doing in this section. We'll see some examples on the next page.